All right, this is 9.2, and it is about the mean. Could I have a volunteer read our learning target where it says LT for learning target? Swara? Thank you. So what is the mean? The mean of a data set is the sum of the data, so adding it all up, divided by the number of data values. So adding all of your values and dividing by the number of values that there are. The mean is a type of average. So whenever you hear someone say like the average amount of rain in the month of April or things like that, when they say the average, this is one calculation you can do to get the average. So yesterday, when we were talking about statistical questions and we said, well, there's not just one answer. That is true. And so one way to kind of boil down all of the data into one reasonable answer or reasonable average is to find the mean. So our first example says the table shows the number of text messages sent by a group of friends over 1 week. What is the mean number of messages sent? So step 1 in finding the mean is to add all of the numbers. So I'm going to take all of these and I'm going to add them. I'm not going to write them all added together because I think if we write add all, we know that in your calculator you would add all of them. I'm going to tell you when you do that, you get 721. That right there is not the average yet. I still have one more step to do. I will tell you though, some students will pause right there. How could I look at that number and say that definitely is not the average of these? Why would I know that's for sure not the average of these? Emma? Yeah, and our average should be like describing the average of these values, meaning it should be close to those numbers. So that's when we should go, wait, I forgot to divide. So now I'm going to divide by the number of data values. Can somebody tell me how many data values there are in this set? Logan? So I'm going to divide it by 7, and I get 103. So C is the correct answer. This means that on average, AVG is the abbreviation for average. These people sent about 103 texts. Each of them sent about 103. So some sent more than that, some sent less than that, but that's a good average descriptor of how many were sent. Questions about example 1? Okay, before we do our next one, I do just want to tell you, so if I type all of this in, and I get 720, I add it all, I get 721, I divide by 7, I get 103. If I type all of this in, 120 plus 95 plus 101 plus 125 plus 82 plus 108 plus 90, so I've typed all of it added together, and then I'm also going to put the divided by 7 on the end, okay, because that's what we're going to do. I get a totally different answer. What is wrong, do you think, with typing all of this in at once, all of the adding and the division at the end? What is potentially happening there? Aaron? And in GEMDAS, the division comes first. So if we type it all in, it's going to do 90 divided by 7 first, and then add all of the numbers. We don't want that. We want to add all of them first and then divide. But what do you think you could maybe include when typing it into your calculator so that you can type it in all at once if you wanted to? Ethan? You could put parentheses around the addition. I'm going to do it real quick just to show you. 82, 108, 90. Okay, see how I put a parenthesis at the beginning as well. You can't see it, but I put a parenthesis right there as well. And then I put divided by 7. And now I get the correct answer. So just be careful when using your calculator for the mean. Make sure you either add all of them, press equals, and then divide, or use parentheses around your addition, because the addition needs to come first, and in GEMDAS it doesn't, so you gotta somehow account for that. We have another term, and that's called an outlier. An outlier is a data value that is either much greater or much less than all the other values, so it's very different from the other values. When included in a data set, it can affect the mean. It can either drag the mean up or drag the mean down. So this table shows the heights of several Shetland ponies. We are going to describe how the outlier affects the mean and then use the data to answer the statistical question, what is the height of a typical Shetland pony? Remember, this is statistical because there's not one answer, but I'm going to use the mean to get a reasonable answer to the question. So first I'm going to find the mean with the outlier, meaning using all my numbers. So I'm going to add all of them together. 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus 38 plus 37 plus 28 plus 40. And I'm going to divide it by 10 because there are 10 values. Remember, in your calculator, you either need to put the parentheses like I just wrote down, or you just need to add them all, press equals, and then press divided by 10. That gives me 37.9. So this is the average. This is saying the average height of a Shetland pony is about 37.9 inches, and this is including the outlier. So what we're going to do next is we're going to take out the outlier and then figure out how the mean is different when we do not include that. You have a question? We're going to get to there in just a second. It is, but we weren't quite there yet. You jumped ahead of me. So now I'm going to do it without the outlier. And Mia told us which one that was. That is the number 28, because it is a lot shorter than the rest of them. The reason we sometimes want to take out outliers is because outliers don't describe what's typical, right? This pony is like a lot shorter than the other ponies, and because that's like not normally their height, we might not want to include it when we're trying to describe the average height. So now I'm going to add them all up again, but I'm not going to include the number 28, so I'm going to skip over that. So 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus 38 plus 37, skipping 28, so then jumping straight to adding 40. What would I want to divide by this time? Would it still be 10? Would it change? Lisandro?
We would divide by 9.
Correct, because now I only used 9 of the values. I took away one of them, so I'm going to divide by 9. This time I get 39. So when the outlier was removed, I got a higher mean. That means the outlier was dragging the mean down. Having the outlier caused a lower mean. Why does that make sense that this outlier would cause a lower mean? Hayden?
You divide, I did one less.
Yes, but I'm also adding less. How does this specific outlier, how would I maybe know that was going to make the mean go down, having it made it be lower? Aubrey?
Because it's much shorter, so average, we will have to put that one at the lower end, so we have to go both of them.
Yes.
So if you don't have that, then in between
Exactly. When we have a outlier that is smaller, it's going to drag that mean down. Like Aubrey was just describing, we have a bigger range, so that kind of is going to have to shift. Whereas when we remove it, now my numbers are closer together. My average is going to go up closer to those numbers. Now, if my outlier had been much greater than all of the other data, it would have caused my mean to be higher than it would be without it. So the outlier can drag the mean down if it's lower than the rest of the values, or it can push it up if it's higher. In this case, the outlier lowers the mean. One thing I want to caution you on is I've had a lot of students on this question go, oh, it made the mean go up because look, it went up. Yeah, it went up when we took the outlier away. So with the outlier, it was lower than without. Now, the last thing it said to do is to answer the statistical question, what is the height of a typical Shetland pony? Which number do you think is better to use? This average with the outlier or the average without it? Dash? So I would say that the typical pony is about 39 inches tall. Because again, that one pony that's 28 inches tall, yeah, there was a pony that was shorter than that, but that was not typical. Most of the ponies are closer to this 39 inches tall. Questions about that example?